Hey everyone, welcome back to our channel Python with GEC Bharuch. Today we are diving into something really exciting, which is advanced feature in Numpy. So let's get started. Before discussing the whole content, let's look at the topics to be covered. So first is advanced indexing and index tricks with subtopic indexing with boolean array, the ix function, indexing with string. Second is tricks and tips, which include the automatic reshaping, vector stacking and histogram. And lastly, we will discuss about file handling with reading and writing file in Numpy. So let's start. First up, let's talk about advanced indexing in Numpy. So Numpy offers more indexing facility than the regular Python sequencing. In addition to indexing by integer and slicing, as we showed before, array can be indexed by array of integer and array of boolean. So let's see both of them using example. So we will discuss about indexing by array of integer and then we will cover index by boolean array. In Numpy, you can use array of integer to index other array. This feature is known as advanced indexing. When you use an integer array as an index, Numpy will select element at the specified position, allowing for more flexible and powerful data manipulation. Let's understand using following example. Here in this example, we have created 1D array of 10, 20, 30, 40 and 50, and now you want to grab specific value, say that second, fourth and fifth element. All you have to do is create an integer array as given in this example, and using advanced indexing it will give the output 20, 40 and 50. It is also similar for multidimensional array. So now let's talk about indexing with boolean array. When we index array with array of indices, we are providing the list of indices to pick. With boolean indices, the approach is very different. We explicitly choose which item in the array we want and which ones we don't. The most natural way one can think of for boolean indexing is to use boolean array that have the same shape as the original array. Let's understand using example. Boolean indexing with 1D array require only 3 steps, in which first is creating an array, second is creating boolean array by applying a condition to the original array, and third is indexing. So in this example, we have created a 1D array which is 10, 20, 30, 40 and 50. Now you only want the number greater than 25. So here created a boolean array based on condition. It create a boolean array behind the scene where every element that meet the condition become true and other become false. And in this example, we have used the boolean array to index the array using boolean indices, and it will give the 30, 40 and 50 is the output, which is greater than 25. Next, working with multidimensional array boolean indexing is also similar to 1D array which we discussed recently. So in this example, we have created 2D array and put the condition that create a boolean array for element greater than 5, and same use the boolean array to index matrix using boolean indices, and it will give the 6, 7, 8 and 9 as the output, which is greater than 5. Now let's move on to the ix function. This is a handy tool for working with multidimensional array. Think of it creating a grid of all possible combination of rows and columns from an array. The Numpy function is convenient way to create an open mesh from multiple sequences or an array of indices. It is particularly useful when you want to select specific row and column from a multi-dimensional array in a way that allow for all combination of the selected row and columns. It's great for handling complex indexing in 2D array. It uses numpy.ix argument as a syntax. Here is a quick example. As we have created 2D array as shown here, and define the row and column indices. So for row indices, we want to select first and third, and for column indices, we have selected second and fourth column. And now we will use numpy.ix function to create a mesh grid of indices, and it will give the 2 and 4, which is in first and third row, and 10 and 12, that is in second and fourth column. So let's move on the interesting fact that NumPy can also handle string. In NumPy, you can also index and manipulate array that contains string. While NumPy is primarily designed for numerical data, it does support array of string through its data type, dtype U for Unicode string and dtype S for bytes. Here we will understand how to create, index and manipulate string array in NumPy. So it is possible in two ways. First is basic indexing and second is Boolean indexing. Here we will discuss basic indexing. Here in this example, we have created 1D array of string, that is apple, cherry, grapes and mango. Now just like numbers, you can use indexing to select or manipulate specific element. So here if you want to access the first element, simply you can give the index number which is 0. So here for apple, and multiple access of element is also possible, which is 1 and 3 using slicing. It will give the output apple using a single element and cherry and grapes from multiple element access. So let's see second way, that is Boolean indexing. In this example, simply 1D array of string is created of apple, cherry, grapes and mango. Now if you want to string longer than 5 characters, then you can do using condition same as Boolean indexing of array. At last, use Boolean array for indexing, and you will get cherry and grapes as the output, which is greater than 5 characters. Now let's look at the couple of tricks and tips you can use in NumPy. So first one is automatic reshaping. NumPy can reshape your data for you without you having to calculate the exact dimension. Let's understand from the given example. So first we have simply used np.arrange 12. It will create an array from 0 to 11. And now using array.reshape 34, we have reshaped the array to 3 cross 4 array and print them. So it will give the output as given here. Left hand side is our original array and right hand side our reshaped array of 0 to 11. Another tip is vector stacking. Imagine you have two arrays and you want to combine them. So you can use vstack to stack them vertically or hstack to stack them horizontally. Now look at the given example. As firstly we create a 1D array. Now using vstack, both array 1 and array 2 will stack vertically and print them, and using hstack, both array 1 and array 2 will stack horizontally and print them. It will give the output left hand side is horizontal stack and right hand side vertical stack is used for array 1 1 2 3 and array 2 4 5 6. Next up, histogram. Histogram are fantastic way to understand the distribution of your data. Let's break down the example. So firstly we have import numpy as np for numerical operation and matplotlib pyplot as plt for plotting graphs. Next, using random.rand integer, we can create array of 100 random integer between 0 and 9. np.histogram calculate the histogram of data and it divide data into 10 bins and return 2 array hist, which count of data point in each bin, and bins for age of bins. Next it will print the result. Now plt.hist plot the histogram using data with 10 bins. Edge color is equal to black, which add black outline, and alpha is equal to 0.7, which makes a bar slightly transparent. Title X label and Y label add the title to the plot, label X axis values and Y axis frequencies. Finally, plt.shows function display the histograph. This is the output of histogram. And finally, let's talk about file handling. So, reading and writing files. Numpy provides several functions to efficiently read and write files, allowing you to handle large dataset in a various format. First is use numpy.save function and numpy.load function for binary files. Second, use numpy.saveZ function to save multiple array in a single compressed file. Third is use numpy.savetxt function and numpy.loadtxt function for text file. Here for writing binary files we have created an array. Now save to array to .numpy file using np.save function, and for reading binary file use the np.load to load the array from .numpy file, and it will display the output like this 1 2 3 and 4 5 6. For writing multiple array files into single compressed file, we have created another array named as array2. Now we have used np.saveZ to save both the array to .npz file. Remember, here we have also used previously created array which was array1. Now for reading a file we have used np.load to load the from .npz file, and it will give the output of both the array as for array 1 1 2 3 4 5 6 from previously created, and for array 2 7 8 9 and 10 11 12 which is we have created in this example. And lastly, for writing text file, numpy.savetxt to save the array to a .txt file, and use np.loadtxt array.txt which is file name to load the array from the text file. As output it will give the 1 2 3 4 5 6 with delimiter which we have used in the code. So here we have covered everything from basic to advanced in indexing. If you found this video helpful, don't forget to like, subscribe and hit the bell icon for more tutorials. Thanks for watching.